this is John from caveofprogramming.com, and in this tutorial we're going to look at anonymous classes in Java. So anonymous classes are basically a way of either extending an existing class or implementing an interface in such a way that you can just do it kind of one time as a one-shot thing, which is often quite useful. So let's take a look at a couple of examples here. And I'm going to create a class here to act as a parent class, and I'll call it machine, and let's give that a method, public void start, and I'll just put a sysout in there, and let's say starting machine. So just a really simple class with one method. Now to create a new object from that class, of course I say machine one, let's say, and this bit is just a variable declaration, so it's not actually creating a object, and I point this reference variable here at an object, a new object, by saying equals new machine. And so here we've got an actual object, an actual instance of this class, a sort of an actual thing that's been created from this blueprint, which among other things contains this method. So I can now run start by saying machine1.start, and of course if I run that, we'll see After Eclipse has had a bit of a think down in the console. Hopefully we'll see starting machine, and here we go. Now the way an anonymous class works is, let's say I want to override this start method in machine. Of course the normal way to do it is you create a class, let's say camera, and you say that it extends machine, and you implement the start method in there, overriding the one in a parent class. But I can also open a curly parenthesis here and put the closing one down there. This looks a bit surprising if you haven't seen it before, and in this space here I can actually override methods. So I can say for example public, let's have an override annotation just to double check that I am overriding the right method. I can say here override public void start, or I could use a shortcut in Eclipse here and just right click and go to source override implement methods. That would also work. And then here I can supply a new implementation, so I can say let's say camera snapping. So now if I run this, it's running the start method in machine, but I've overridden that here. And if you look at this object, the one that I'm creating by doing new here, you could ask, like, well, what is the class of that object? It's not machine. Okay, the class of the variable, the type of this variable is machine, but this thing is actually a child class of machine. It's not machine itself because it doesn't have the machine implementation of this start method. It has an overridden implementation as though you'd done extends on the class. So actually the type of this object is some child class of machine that doesn't actually have a name, and that's why it's called an anonymous class. And with anonymous classes, there's no way that you can create a new object from this class here, but it's good as a one-shot thing. If you just want one example of some class that's a little bit different to an existing class, you can use an anonymous class syntax like this. Let's just take a look at one more example here. Let's supposing I have an interface. Let's say interface, what should we have? Interface plant, let's say. And let's say that the plant interface, I could give it lots of methods, but I'll just give it one as an example. So I'll give it a public void grow. And yeah, because it's an interface, of course, we don't have any code, so there's no curly parentheses. We just have a semicolon there. Now to implement this interface, I could create a class and say that it implements plant, and then I'd be forced to add a method to that class with this header. But another way of doing this is to use, again, an anonymous class syntax. So I could say here plant1 equals new plant. Now this isn't going to work in itself. It's going to give me an error saying cannot instantiate the type plant. Instantiate means create an object from the class or the interface, and you can't instantiate interfaces because there's no code there to actually put into an object. So this syntax for an interface is not legal in itself. It's just as if I'm kind of pretending here that plant is a class, but it isn't, and so this won't actually work. But again, what I can do is open a curly parenthesis and put the closing one in there, followed by a semicolon at the end. And now in here, actually the quickest way to do this is to click on this error and add unimplemented methods here. And now I can implement the grow method of plant right here with this anonymous class syntax. I don't need this override annotation. In fact, here it seems strange that we say override to implement the method in an interface. It is a sort of override, I suppose. But anyway, leaving that aside, let's get rid of at least the blank lines. And this override annotation is not necessary. I could delete it. And let's put in here sysout plant growing. And now I can declare a variable of this type, the type of the interface. Well, actually I already have done here. And then I can say plant1.grow like that. So I can call the method of this anonymous class which actually implements this interface. I need to say grow there, and once again if I just run that now, save it and run it, then it's going to say plant growing. So that's it for this tutorial, and in the future we're going to look at some more examples of this, because often what you do is you declare an anonymous class while you actually pass it to a method at the same time, and that's often used for the kind of listener event pattern, which is, I notice, is tremendously confusing and difficult for beginners in Java, just because there are several different concepts all in one kind of just in a few lines. And this is one of the concepts that you'll need to understand how event kind of listeners in GUI programming are often implemented. And even if you're not doing any GUI, that's graphical user interface programming, you can do all sorts of things with this technique, which I'll go on to show you in future tutorials. Thanks again for all the fantastic comments that people have left on YouTube and on caverprogramming.com. It really makes it worthwhile creating these videos, so many thanks. And this code's going to be on caverprogramming.com, and I hope you'll join me again next time. Until then, happy coding.